So look at the board. We're going to solve some calculation under this man. I will give you tips on how to know the calculation. Faraday laws of all the calculation under electrolysis is all about direct proportion. It's all about what? Direct proportion. If you read the question, you understand that it's all about direct proportion. They ask to calculate the mass of silver. Mass of what? Silver. Deposited. I have told you that when they say mass of this deposited, mass of this connected, mass of this applied, mass of this at this, it means direct proportion. You understand? So they ask you to calculate the mass of silver deposited when a current of this is passed through a solution of this. The mass deposited when this pass through this. You understand? They can use mole to ask you this question. If 1 Faraday deposited this mole, how many moles will be deposited by this Faraday? Do you understand? It's very simple. It's a direct proportion. If 1 Faraday, just what you need to know from that electrochemical studies I give you, knows their number of ion. Not the one that has 2, not the one that has 1, not the one that has the up. You understand? I'm giving you on the electrochemical studies where I told you that silver used to have 1 ion, 1 charge. So 1 mean 1. Do you understand? Potassium 1. The one that has 2, you use 2 and times Faraday. That's the only thing you will do. Aluminium has 3. This one has 2. You understand? Gold 1. I have shown you that one. Copper 2. So if you discover you use 2 to times Faraday, complete the number of charges, the number of electricity there. Do you understand? So this mass is very simple. This mass is very simple. Do you understand? So see what you will do. Faraday is talking about electricity. This electricity is another electricity. Do you understand? So this one are comparing with the molar mass. Are you hearing me? They are comparing with the molar mass. This one we compare with the molar mass. Then this man we compare the electricity again in the equation. We compare with the mass because they ask you calculate the mass of silver deposited when the current of this is passed through the solution. Do you understand? So what we do? The mass of silver is not too hard. The mass of what? Silver is directly proportional to quantity of electricity passing through silver, which is this. Quantity of electricity passing through silver. I get me? Then the molar mass of silver, another mass, there's a direct proportion. See it here. It's not directly proportional to what? Directly proportional to what? CF. Number of charge. And Faraday. Faraday is talking about quantity of electricity. Are you not seeing you compare this with this and compare the mass with the other one? That's how to do it. Do you understand? You compare this with this and compare this one with the other one. So the max, I don't see where they ask what is the max deposited when the current of this is passed through solution of this. So the max is compared with quantity of electricity. Then the molar mass we compare with the Faraday. Faraday is talking about quantity of electricity. Do you understand? And the charge. The mass is very clear. Do you understand? When we do the second one, you understand it more and more. Are you getting me? So if you know this, you will solve all the question under Faraday. Faraday first law, solve it neat. Even when they ask you if a mole of this deposited at this, it's a direct proportion. You solve it fast and fast. You understand? So now look at the board. We don't know the mass, so the mass is x. So the quantity of electricity we deposit is what? But after that, formula for quantity of electricity is IT. We don't have Z. If we have Z, we put ZIT. That is constant, but we don't have Z, so we take this one. Quantity of electricity, we say that is IT, which is equals to 2.6 times current is 2.6 times. You convert this one to seconds. Time is converting to seconds. 70 times 60. Do you understand? So molar mass of silver is 108. Deposit dash. Number of charge on silver is 1. I've shown you that one on my electrochemical during our electrochemical series. Go and study those series. Know the charge attached to each of them because you use it to solve all the marks on Faraday's. You understand? Times what? 96500. So we clocks and multiply. So if we clocks and multiply, we get, so it will be 108 times 2.6 times 70 times 60. Everything over 96500 Faraday. So now our max xg, mass of this will be equal to this times this times this. Let's check it. Jamb is going on live on my YouTube channel. Jamb question is going on live on my YouTube channel. So let's do the calculation with our calculator. So 108 times 2.6 times 70 times 60 divided by 96. So it is 12.2. 12.2. So after set and done, after multiplying this, you get what? What will you get? Let me do so that everybody will understand. So you get what we got? We get 179,360. Now divided by 96,500. It will give you 12.2 gram. Jamb is going on live on my YouTube channel. Jamb question going on live on my YouTube channel. Jamb question is going on live on my YouTube channel. That is how to solve Faraday law of electrolysis under the calculative aspect. That's how to solve it. Once you know this, you know peace. Jamb is going on live on my YouTube channel. Jamb is going on live on my YouTube channel. Jamb is going on live on my YouTube channel. Jamb question is going on live on my YouTube channel. Thanks for watching.